Okay, so as I was saying, we're doing clean data. It's kind of dull, but it is also really fundamentally important. And there's a lot of R coding that you'll actually do depending on how you've got your data set. What by the end of this class, hopefully what you'll know how to do is to run all the setup commands in R that are just sort of the background so that the commands that like Young's class and I'm giving you actually run, because many of them won't work unless you've loaded all the right packages. They're also there just so that there are other ones that I put in there so that your computer won't freeze up when it opens view, like when it views your data set, because now you're dealing with some pretty big data sets. Then you've got 20,000 variables or 20,000 cases. That sort of stuff will just make your computer stop for a long time and hang. I've gone through and actually shown how to download your article and its data and its code books for 3 different websites. And it's just, most of you should have already solved that, but those who haven't, it can be a bit of a hassle. We go through importing data, again, I think pretty simple. We've done it before, but it can be important. I've got some code here today that allows you to generate a code book. So from the data, so if you can imagine what you're going to have as you do this is, because today it's all about checking, basically. Today it's all about making sure that 3 different things, 3 different sources are all doing the same thing, or at least 2 of them are. The 3 are the article, which is in the data and method section. And actually, you'll also look at the univariate table. It's amazing how much is not said, but it's sort of somewhere where you can find it. You're going to look at that and go, oh, how were they measuring it? What did they do, etc. Then you're going to compare that with 2 other things. There is the official code book, which should be with your data, should be downloaded as a PDF. And that tells you what should be going on in the data set. And then you're going to make your own, I've just called it your R_code book. And in that, it will be whatever you've actually got on your computer right now. Right? It'll generate a code book for you. We'll have it as a HTML file. You can regenerate it as you're doing your recoding and so forth, but I've given you the code I'll give you the code to do that. And what I need you to do is you need to read through, well, actually, what we're going to do as the exercise today is very simple. You're going to go through the article and say, what are my top 5? Because we don't need to do all of them, but let's pick the top 5. Even if you just get 1 done today, it's fine as well. What are the top 5 variables that really matter? So they're going to be your dependent variable, and then some of your key independent variables and controls. Yeah, just write down 5 of them that you're going to do for today. And then you're going to go through and after you've generated your R code book, is compare these 3 documents, right? So this is the main part of it. You're going to compare your article, the official code books, and your real code book, and write out a list of what you need to do. It's pretty straight. And again, the best way to do this is just to do it by hand, either on paper or on just a plain Word document or such, and you'll be writing down like the official name of it, and then what changes you need to make. So, for example, I'm going to have an example later on where we will go through, and it has in the article it's called political knowledge. In the R code book and the official code book, I think it's called F10, F11, F12, and then I think F16, P01 through to F16, P06, because it's actually a whole lot of quiz questions. And this one is one of the worst, but it needs to be actually recoded so that eventually it just becomes a 0 to 10 scale of whether how many quiz questions the person got right in terms of how Australian politics, basic questions on Australian politics. So what you'll write as you go through your as you go through this step of comparing them is to write down, something. And there's no absolute formula for it, but my suggestion is you write down the name of your variable, and then you write down effectively the name in your R code. So that might be these here, and then you're going to write down the sort of the transformation that needs to happen. Now that's in this case, it's actually a series of things. It's going to be, it turns out you have to change all the don't knows to a 0. Then you need to need to mark all the quizzes, which is ridiculous. But you actually have to go through and say, did they get it right or not? Was Treasurer Bowen really the treasurer in 2013? And then you need to add it together to create your scale. Yep. Terrible, that's probably as bad as it gets. But that's what you're going to do. And then so once you've actually written out just by hand, like maybe in a Word document, what you need to do, you go through and then write the code. And these steps are good, important just so you're really systematic about it, because this is the sort of stuff when you hurry, you screw it up. So write the code, and then the last thing is we're going to generate the descriptive. We're not going to do the histograms today, and we're going to use a bit of piping, which is a relatively recent thing in R. It turns out that this is written in the guide, but I'll just explain it to you just briefly. You've probably seen it with Young. It's a percentage sign, and a greater than sign, and then another percentage sign. And often it's called the then, and the real name for is piping. And I've got to tell you, I've known about this for a couple of years, and I'm just like, why do we have this? This is so silly. Why make life more difficult for ourselves by adding this in? But it turns out to be quite remarkably useful. And the reason for that is that what it does, what more whiteboard? Here, I'll put it. Can you all see there? Or can you see over here? Yeah. So the way it works is often when you're running a command in R, you want to say, we're going to do this later, but you want to print something. So this will actually send it to a browser. And then you need to create descriptive statistics. So you've got to run a descriptive thing. And then you want to run the descriptive command. And then you actually want to select just a few of your variables from within that. So then you do select, and then you'll have a series of variables X, Y, Z, A, blah, blah, blah. Now, that sort of is fine, except actually after each one of these, we actually need to put in a series of other commands. We want to select actually, the statistics might be, I don't know, it might be statistics are equal to min, max, and blah, blah, blah. And it gets very complicated very quickly. And you're like searching for the brackets, yes? How does it solve it? Well, basically, the way it works is that if we wrote this in simple terms, if we just wrote this as P, D, S, X, right? We can transform that. You can see that. That's what we can transform this equation. So it's function P, function D, function S around a variable X. Using the magneto, the piping, we transform it by going like this. We say, take my data set X and put it into S. And then, on the new line, put S into D, and then put that into P. So it says, take X, select the right variables, run a describe, and then print it off for me. And it actually, you'll see as we go, it's much easier to read. I know this is not all going to stick in your head right now, but are you following broadly? And it turns out that it just becomes a lot easier to read. Each thing it does is on a line, and you're not constantly trying to juggle between these brackets. I promise you it just looks a lot nicer once people stick it online. I've got an example on here that actually didn't suffer from my little technical failure, so let me just pull it up. So this is from last week that we didn't actually do, but this is an example of it, which I've got used it again this week. So that command is the equivalent of this set of commands here. That's it, is just theoretical, but then actually what we do here is this is from Jack's data. He's gone select these variables, and he's going to then try and describe them, and he's going to then print them, and you can do it as this one set of command where you go select and then put the selected variables into this to describe it and give me the mean, standard deviation, minimum, and max, and then print it out on the browser. And it does it. It's much easier to read than if we had all these things nested inside of one another. Does that make sense? Yeah? Whatever. It's it just is, and it's much better. So what I'm going to suggest is what I want you to do is to simply start by first going to the setup and installing these, running these functions. This one here, this is just the required packages. I run it like this so that it will not reinstall it every time if you haven't already installed it. So you can just cut and paste this code. These are the libraries. This one here is to turn off scientific notation. And this one here says simply only give me 500 lines of code to stop me overloading my memory. And in fact, I've put it all at the bottom here so you can just cut and paste it straight into yours. Run that, and then take a look at downloading the data sets, and I will try and get the other 4 things up ASAP. There's something going on behind the scenes. Yeah. And if I can just ask, can you do me a favor? Can you put up a green sticky if you've got a data set? And can you put up a red sticky if you don't have a data set? Okay. Those who don't have data sets, I'm just going to say, for today, can you pick one of the 2 data sets from last week? Doesn't matter which one. And just you've got the article there, you've got the code books there, and you've got the. So there's the 3 of you, you as well. Yeah. Okay. Right. Pick one of the 2. So there's the one of my data set, and there's also the. If you look here, I'll just pull it up. So if you go to 3.0 overview, at the bottom, there are, oh no, not there. Where is it? Exercise concepts. Here, the example data set. So there's McAllister, and there's my thesis. And here we have the article, the full data sets. Use the full data sets for this exercise because we're doing cleaning, and the full code book. Good? Yeah, so just get yourself started, get those things imported, and I'll get the rest of the code up there so we can go on. What questions? Okay, they're there. So if I can just take you through very briefly what we've got. Do you want me to just show you this? Do you mind if I just take you through very briefly what's on there? So so we have setup. It has the install, load, turn off scientific notation, stop view from overloading your memory, and then all the text you can cut for it. Downloading data sets. We have how to download from ICPSR, how to download from andrewlee.org, how to download from the Australian Electoral Survey. They're all pretty similar. Basically what happens is you download a zip file, and then inside the zip file, you've got to open the zip file and extract it. and then inside it will have codebook and the data set. I recommend downloading as SPSS if you have that option, which will be a .sav file. You can't open that on your computer natively, but you can import it into R with the commands we'll use. Andrew Lee does similar, and the Australian Electoral Survey has, again, similar sort of stuff. Yes? And some of them will also have things like the questionnaire in there as well. Then you can import it by running this. I've just put this code at the top every time because nothing will work if you don't run this code. And I just presume people may come to these pages without having run it. So you can run SG labeled read SPSS. There's actually, Jack has the opinion that using the function in R is better. So to just go to import dataset from SPSS. So sorry, you can't see my code here, but so import dataset from SPSS is a better function to use, whatever. Generally, it's recommended to transform it to what's called a tibble, which is just simply a more data efficient form of the data frame. And then this is how you create the codebook. It's using the package that we've already loaded up here, summary tools, but it's view df. You just simply, and I've put a few function things in there to make it, I think these are better than the default settings. And it will make it appear in the viewer down in the bottom right-hand tab here and if you press then that button, this little arrow and inside a browser, then it will come up in your browser with the full data thing. And you can actually, what you can do at this stage is actually save it as a HTML file somewhere on your computer. So you could just simply go, like say it was this page, you could go file, I think it's here. I'll just go to my one. Oh no, it's not that. You could go, just any HTML file, you can simply go up here and go save page as, and just save it somewhere on your computer, and it's now your codebook as an HTML file that you can open anywhere. Moving right along, in terms of planning your cleaning, again, you basically just want to, these are the sort of things you want to do, which is just to go through and work out what the name is, the variable name, and then write down your issues or problems. Sometimes it can be as simple as just saying I need to transform 3 to 1 and 1 to 2, 3, 4, and 5 to 0, and -1 to NA. Other times it's going to be more complicated than that. It's recoded my, yeah. So there's examples like that, and that's your planning, your cleaning, and then for recoding, these are all the main things you might end up doing. So you've actually learned all this from Young. Most of this is from Young's website. I've just consolidated it together. So always using that the function FRQ, F-R-Q, frequency, to get a quick look at any variable you're recoding. It'll give you the value. It'll give you the labels. It'll give you the percentages, which is very handy. Recode, this is how you recode. You use frequency just to check. You can do a calculate with a function like this, which is, but any calculate, you could just basically, if you need to change something, the main way that the thing that you'll have in terms of calculation will be reverse coding. So you'll find that something is most likely is 1 and least likely is 5. Yeah, you need to switch it. This is actually the equation for it. You take the minimum of the scale and the maximum of the scale, add it together, and you take away the old variable. It sounds weird, but it turns out to be correct. I could do it with you. Do you want me to just explain that? Or you get it? You get it? Or you want me to explain it? But you normally can do it by hand. You normally don't need to. So it turns out that this is one of the, once I explain it to you, you're going to be like, oh, that's simple. But it turns out that, let's say we've got a scale Let's write it over here. Say we've got a scale that says 5 is strongly disagree, 3 is neutral, and 1 is strongly agree. And we're like, well, that's a bit stupid, right? It's annoying, right? So how can I recode all of my, 20,000 people's variables very quickly with it? Let's say this is my variable called, we'll call it Likert. It's a Likert, right? So my Likert scale is called this. The way we can recode it is just sort of, we can say, I would do something like REV underscore Likert. Remember, Likert's just a name. And then we put into it, turns out if we take the add 1 plus 5, it's 6. If we just do 6 minus Likert, we will actually reverse it, because what's 6 minus 5? 1. What's 6 minus 3? 3. What's 6 minus 1? 5. And all of a sudden it all makes sense. Now, it's really weird, like that's like the most simple like year 2 maths or something, but it turns out to be almost everyone needs it explained to them, including me and everyone I know, and it's really cool and it just makes your life really simple. So that's one for recode, reverse encoding. Got it? Constructing a scale, it's just the same thing, you just add them together. So in this case, say I had actually recoded my 10 questions, so you got 1 if you were right and 0 if you were wrong. You add them all together and you get a 0 to 10 scale. Yep. Does that make sense? Creating dummy variables. This is straight out of Young's code, but we're recoding various variables here, and it's quite straightforward. You just often need to reset the labels as well. The only complication here is these two things, which is if it is a dummy, if it is a binary, or if it is a categorical variable like race or ethnicity or language or something like that, then you want to use this two-factor. What we're doing here seems boring as hell. Anyway, yes. The reason why you want to do this is because it will behave a lot nicer in all your models. You may understand a reference category that will only be relevant when you get up to doing regressions. That's actually how you do the baking them for those. If you need to remove a variable, this is the function. So if you've created something, you don't like it, you want to remove it. And you can reassign new value labels as Young taught you. Yep. And then I think there's just one last thing on here, which is how to create the descriptive statistics, which I've sort of already explained. We have the piping function. Simple way is to use select, so you don't, because you may have, you'll have 500 variables in your data set. Pick the 5 or so that you want, using this describe function to get the variables you want, and print. The only thing that I've added in here, which Jack and I found today, is that if you use the as factor on anything, then this function will ignore it and will give you the descriptive table. So you won't get descriptives for gender if you don't put that as numeric. Whatever. Annoying, but nonetheless true. Are we good? So are we clear about what we're going to do today? Does it sound like a worthwhile use of your time to do this? I think it's really good practice, and it's so yeah, I do anyway. Have you? Jack's already done it all, I think. You can be teaching assistant today, Jack. Okay. All right. Does anyone have any questions? Yes.
Oh, well, just a minute.
Yes, Mike.
My data set is a Likert scale.
That's good.
But I'm going to do regression. That's with the ordinal variable.
Yeah. So there's two things you can do. you can just run it as a linear regression and violate some assumptions.
Something more like that.
And actually, we can actually, you and I can sit down for about half an hour and we will find we can run an ordinal regression on it, and it's not very difficult. It's like finding the command and running it, and you know what will happen? 99 out of 100 times, it'll give you the same results. That's right, all right, but that's fine. You can present both of them.
Okay.
Perfect, and it won't be a problem.
I just didn't want to get to the last one.
No, it's not. It's not. It's really not an issue. It's not an issue. Anyone else? Okay, let's go. Just pick 5. I mean, you can keep going. I mean, you're going to have to do a lot more by week 7 anyway, so just start with 5. I mean, the thing I wanted you to do, and I just to say in terms of sharing and also seeing that we're all working together, also like pasting what you've done, and also once you've done it, to go and paste it into your code and maybe some of your results into the Google Doc for this week. Then we can see what people have done. Is that all right? So I will just make that's the bit.ly, and I will make a new one for this week. Yes?
So it's data.
Yeah, so we can import it as a state file. Yeah. How annoying. It's okay. That's really not unusual at all, even though it sucks. Code books are a lot of work. Yeah, so, yeah, that's, try that, so run it. Is it auto? Is that what it's called? Oh, you put it into auto, yeah.
Well, I wasn't much sure why that code auto.
So auto is you've given it the name auto. So can I just say, the code I tend to use for data sets, and I don't know whether this is good or not, I call always, because when you import your data set, you can call it whatever you want. I always call mine DS. Why? Because it's longer than D, in case someone creates a variable D, but it's quite short, so that when you're typing, it's really fast and easy to use. And it's not, a lot of things use the code DF, but DS for data set, you can use whatever you want. I wouldn't recommend using something as simple as X or I or J, but something short makes your life easier. Yep. So you actually, so I do know we can, I